Hello everyone, this is Dr. Webb. In this video we're going to talk about how you can take a double integral and reverse the order of integration. So let's say it's written originally it's written where in terms of integrating in terms of x first, and you want to swap it so that you integrate in terms of y first. Now if you look in most calculus textbooks, this topic is kind of stuck in the section that talks about double integrals over general regions, and maybe it has a paragraph, probably one example on it, but it's not really given much more attention than that. But I think this is actually kind of a tricky thing to do in practice, and so we're going to pay it some special attention by giving it its own video. So let's just jump right in with an example. So let's say we want to evaluate this integral. So we're integrating e to the x squared, first in terms of dx, where the bounds are x goes from 2y to 2, and then in terms of dy from 0 to 1. So looking at this, right off the bat, we're trying to integrate e to the x squared in terms of x. And this is just an impossible thing to do. So integrating this right here, this is impossible. And coming out with a nice function at the end. There's nothing we can use to do this. Integration by parts won't work. There's no special u substitution that makes this doable. This is just a impossible integral. It's an integral that we cannot evaluate nicely. So what we're going to do is we're going to figure out, we're going to swap the order of integration by rewriting the region so that we integrate y first. Okay, and that maybe by integrating y first, after that integral, then what we're left with will be an integral that we can then do in terms of x. Okay, so let's look at this region. So going through these inside bounds, x goes to 2y to 2, that's our bounds for x. So we have x is going to be greater than or equal to 2y, less than or equal to 2. And then our outer bounds are talking about y, and it's telling us that y is going from 0 to 1. Okay, so let's try and draw this region out. Okay, so our bounds for x, so x is equal to 2y, that's the same thing, x equal to 2y, that's the same thing as saying that y is equal to x over 2. So that's a line with slope 1/2, and then we have x equals 2, that's a line going straight up. And then our bounds here for y are going from 0 to 1. Okay, so let's be clear about where the region is here. And so really at this point we're kind of undoing what we did in the last video in terms of taking the region and figuring out how to express it in terms of bounds. Now we have the bounds and we're trying to figure out what the region is. Okay, and so if we're looking at this, the y bounds are saying pick a y between 0 and 1. So there's my y between 0 and 1. And then it says the region is all the x values starting at 2y, so that's on the line, and going until x equals 2. So all the x values right there. Okay, so that yellow line there is inside the region, and so that's telling us that the region here is going to be this triangle right here. That's all the places from y equals 0 to y equals 1. Okay, so now we want to reverse this, and so when we drew this out, we used a horizontal line. So if we're going to reverse it, we got to think about doing a vertical line. Okay, so for a vertical line, that means that we're fixing some x value. And so what are these x values going from? Actually, let's use a different color. These x values are going from x equals 0 to x equals 2. And then to stay inside the region, going up from the x-axis until we hit this line, which is y equals x over 2. So for a single x value, the y values that we're integrating over start at the x-axis, which is y equals 0. And then we go up until we hit the line, which is y equals x over 2. Okay, and so this is our new bounds, thinking about this in terms of a vertical line instead of a horizontal line. And so now we have this set up to integrate y first and then x second. So our new integral is going to be the inside integral is going from 0 to x over 2 e to the x squared. Now we're doing dy first, and then we're integrating dx second, going from 0 to 2. Okay. So these two integrals are exactly the same, and our hope is the first one, the one originally given to us, was impossible to do, and our hope is that now that we can do this second integral. So let's do this out. Okay. So first we're integrating in terms of y. There's no y's here. The e to the x squared is just a constant. And so working this out, we're going to get e to the x squared times y, as y goes from 0 to x over 2. And then this is tucked inside the second integral. Now plugging these in, plugging in the bounds for y here, I'm going to get x over 2 e to the x squared dx. And then if I plug in y equals 0, that just zeroes everything out. Okay. And now x over 2 e to the x squared, this is now a doable integral. We can do this via u substitution. So if we let u equal x squared, du is equal to 2x dx, and so du over 2 is equal to x dx, and so we can rewrite this integral now as, so x dx is going to be du over 2, and then we've got another 1/2 in there. And so x dx is going to turn into, x over 2 dx is going to turn into du over 4 e to the u. And then our new bounds for u are, if x is equal to 0, then u is equal to 0. If x is equal to 2, then u is equal to 2 squared, which is 4. And so we get 1/4. The integral of eu is just eu, evaluated from 0 to 4, which gives me e to the 4th over 4, minus, if I plug 0 in, e to the 0 is just 1, so it's minus 1/4. We have a very nice doable integral right there. Okay, and so this is a useful trick to do in lots of situations. Okay, so in general, reversing the order of integration, it's a smart idea if we're going to end up with an integral that is easier to evaluate. This is why you would swap the order of integration. And so easier may sometimes mean it's actually an integral you can do. Sometimes easier can mean that it's just a bit easier. But it's sort of, if you have an integral and it looks like it's a bear, or you're not quite sure how to do it, try reversing the order of integration sometimes that's going to give you something that's a bit more manageable. Okay, so things to remember when you're doing this. So one thing is that you need to make sure that you have the correct region that you're integrating over, and that you've written the inverse functions correctly. So what I mean by the inverse functions is if you have your functions start off as being x is equal to a function of y, well then you have to invert them and have it as y is equal to the inverse function of x. And so you need to make sure that you're using the right inverse functions at each time. Changing the order of integration does not change the actual function inside the integral. So the function being integrated does not change. So that's always going to stay the same. When you're done with this, and this is a rule that's same for integrals over general regions, the inner integral bounds can contain the second variable that's going to be integrated. So if you're integrating in terms of y first, the inside bounds can contain x's. If you're going to integrate in terms of x first, the inner bounds can contain y's. Okay. But the outer integral bounds should never contain variables. So the outer integral, really I mean particularly the bounds here, should only be numbers. Should not have a variable in it at all, because at the end of the day, there's no such thing as indefinite double integrals. All double integrals are definite double integrals. When you do the double integral, you're going to end up with a number at the end. Okay, so we're going to do a couple of examples to see, a couple more examples to see how this works. We're not actually going to do the integration here. We're just going to work on reading off what the region is and then rewriting it with the variables reversed. Okay, and so looking at this integral, so our bounds, our inside bounds are in terms of y, and it goes from y equals 0 to natural log of x. So we have y is going from 0 to ln of x. And then our outer bounds are in terms of x, and it's saying x is going from 1 to e. So x goes from 1 to e. So let's draw this region. Okay. So y equals 0 is the x-axis. So there's the x-axis. And then y equals natural log of x looks like this. So this is y equals NL natural log of x. This is y equals 0. And then we have x is going from, our x values are going from 1 to e. Okay, now the way to read this as written is it's saying pick an x value between 1 to e. So that'll be our x. And then it says for those x values, take all the y values above that going from 0, so that's the x-axis, up until you hit y equals natural log of x. Okay, so that's our region there. We're doing this from 0 all the way up to e is the last vertical line we're going through. Okay, so we can see our region here is this bit underneath natural log of x, from x equals 1 to x equals e. Okay, and what's the point that this hits here? Well, this would be the point e natural log of e, but the natural log of e is 1. And so this is the point e1. Okay. So now let's think about how we would write this the other way. Okay, so this way we were thinking about picking an x value and looking at the y values above that. So now we're going the other way. So for the other way, our y values across here are they're starting on the x-axis. So that's starting at y equals 0. And we go all the way up until we hit this intersection point, and that happens when y is equal to 1. Okay, now we're thinking about picking some y value in between, and then we're integrating over the x values inside the region at that particular y value. So we're looking at this green line here. So the green line starts at y equals natural log of x, but we need to write this in the other way. So the inverse of y equals natural log of x, inverting this is going to be x is equal to e to the y, right? Because e to the x and natural log of x are inverse functions. And so that's our starting x value. So the x values start at e to the y, and they go out until we hit this vertical line at x equals e. Okay. So this is our new bounds in which we're going to write the integral. And so using these bounds, the function we're integrating doesn't change. Now we're integrating in terms of x first. In the inner bounds, the lower bound is e to the y, going up to e, and then we're integrating in terms of y from 0 to 1. And so here is our new integral in terms of integrating x first and y second. Okay. So let's do one more example. And so in this example, our inner bounds are in terms of x. And so they are saying that our x values are going from arc sine of y to pi over 2, and our outer bounds are in terms of y, and they're going from 0 to 1. So y is going from 0 to 1. Okay, let's graph this. Okay, so x equals arc sine of y. I have trouble picturing that in my head, so I think I'm just going to invert it right now. So this is the same thing as sine of x equaling y. That I can draw. So sine looks like this. And then it has x going to pi over 2. So pi over 2 is right here. That's x equals pi over 2. And so then my region is for y values going from 0 to 1 is where they hit right there. My x values start at our arc sine function and go until I hit pi over 2. Okay, so this horizontal line here is inside the region. So our region right here is that right there. Okay, so now let's do this the opposite way. So now for the opposite way, I'm going to be picking an x value between 0 and 2 pi. So let's use green. X is starting at 0 and going to not 2 pi, pi over 2. Okay, and then for some x value in between these two, my y values are going from the x-axis, so y equals 0, and they're going up until I hit the sine curve. So they're going up until sine of x. Okay. And so let's rewrite the integral now. So our function doesn't change, but now we're integrating in terms of y first, and its bounds are 0 to sine of x, and then we're integrating in terms of x, and we're integrating 0 to pi over 2. there's our integral. Okay, so you know, the same as integration in Calc 1, you know, especially compared to differentiation. You know, differentiation, it's always an algorithm. There are set rules in how you do it. Pretty much anything with integration, it's a bit more of an art. And so it takes practice to do, but as you go through and practice these, it starts making more and more sense. Okay, so just remember that as you go through and doing these reversing the order of integration, treat it like it's an art. Go through it slowly, and you know, really focus on breaking it down step by step, and then things tend to pop out. That is all for this video. I will see you again soon.